In Chapter 3, we are going to explore the fossil fuels, which are the non-renewable energy. Non-renewable means the rate it is consumed far exceeds the rate it is replenished or regenerated. Out of all the learning outcomes, my focus is to help you understand the environmental impacts of using non-renewable energy. Looking back in the human history, back thousands of years, we use human labor, okay, to do work, and then we discover the power of wind and the water, the hydro energy. And most of the time we use animals to help with the human hand labor. And this is the main form of using energy for thousands of years for humans. We rely on burning the woods for the heat. And this picture shows a lady cooking. And now it's not very difficult for us to understand this form of using energy is not very efficient. Most of the heat dissipates and is wasted. And this is the modern society, how we use energy. We use a lot of energy for lighting, for running infrastructures, and we use a lot of energy on transportation. And this is a home. We use all the appliances, the helpers, right? The machines to help us to do the work, which is highly efficient and also consumes a lot of energy. If we look at the entire human history as a clock, okay, the fossil fuel energy entered this clock in the last 3 minutes. It is very recent in the human history. Non-renewable energy sources are those whose resources are being used faster than can be replenished. I would say much faster. And we are going to discuss coal, oil, and natural gas in this chapter. Usually in the previous semesters, I will include nuclear power also, but in this new textbook, they also want us to understand nuclear power is the alternatives of fossil fuel. So I'm going to talk more about nuclear power in chapter 14. And this graph clearly shows the fossil fuels dominate the energy consumption in the recent human history. If we look at the years, this is starting of the Industrial Revolution, right? We discovered coal, and we start to invent steam machine, trains, and automobile. And you can see in our textbook, we have a much long axis here. So in thousands of years, we use wood and the biomass as the main resource of energy. And in recent 100 to 200 years, coal start to rise and take over the energy market. And then we discover oil. So the oil start to get dominant about 50 years ago. And natural gas soon take over. Okay, so each transaction take about 50 to 100 years. That's a pattern. And today, about 15% of the energy comes from the renewable energy. Renewable means constantly renewed, right? Replenished. And cannot be depleted. I feel necessary to compare these two concepts. One is resource as a naturally occurring substance of use that can potentially be extracted using current technology. That means current knowledge and technology enable us to discover those resources. If you look at the figure here, this is this whole area is resources. A reserve is a known deposit can be used under certain economic conditions. This is really interesting, economic, which means we may know about those deposits, but it's very, very expensive to extract them. It's almost not feasible for us, right? If you spend too much money extract oil, the loss is way more than the gain, and it's not worth. So the reserve is we can use those resources only under certain economic conditions. So reserves are smaller than the resources, right? And it's affected by the economic condition. Now we start to talk about the real stuff. The first I want to start with is coal. So how coal was produced, it takes 100 million years. And this is ancient tropical swamp. After the swamp was buried, especially the plants, they converted to coal under extreme heat and pressure. And it's a long process. So after we use up the coal, it probably takes another millions of years to regenerate. That's why coal is considered non-renewable. And I want you to remember the coal was generated from the ancient plants. And the coal has different compositions and different moisture. If we look at the left side here, those type of coals have higher moisture and lower carbon content. If we look at the right side, the carbon content is much higher and the moisture is content is very low. And they have different names. The very soft, mushy type of coal is called peat, and then lignite, bituminous, and anthracite. And they have different applications too. And the dominant kinds of coal used for power plants are subbituminous and bituminous. And bituminous is very popular, used in power plants and other industry because it's easiest to mine and most abundant. It supplies 20% of the world's energy requirements. This figure shows a coal reserve. Okay, so Europe, Asia, and North America have most of the coal deposits. The environmental impacts, we talked about this before. We talked about the mining before, right? And the bad thing is we have to remove the mountaintop sometimes, so we destroy the ecosystems, right? Because we dig underneath, so the sulfur buried underneath was exposed and was dissolved into water and released to the air. This graph shows different methods of mining. We have underground mining methods. We have regional land surface here. This is dragline removing mountain top. So this is remove the mountain top, okay? And we also have slope mine, drift mine, depending on the depth underneath. So this is a destructive process. That's why we say there is no sustainable mining. And this is the environmental impacts of coal use and the mining. Okay. I just changed the title here. Although mining is part of the coal use, I think the impacts of mining is more appropriate for this slide. The water contamination, soil contamination, destruction of the ecosystem and cause land substance. This shows you if this area collapse that will cause the land subsidence. And the burning of the coal release tons of air pollutants. Mercury is released into the air when the coal is burned, and the mercury can be bioaccumulated and biomagnified. Carbon and sulfur are the main air pollutants, and they cause the acid rain. There is no sustainable mining, so the only thing we can do is reclaiming the mining sites. It's a long process, but it could be done. Not all of them could be reclaimed yet. We'll do a case study later. But this is a sustainable way we restore the ecosystem.